My name is Zakhar. I am the security engineer at Wrike. So today we'll talk a little bit about the application security. That's the main part of my job at Wrike. I'm the application security engineer, and I will talk about the dynamic application security testing tools and how we involve our security of dynamic testing at Wrike to meet the requirements of everyday deployment and when you have to qualify the software from the security perspective. So a couple of words of what is static application security testing tools, because you will hear this word a lot of times. So I will use the acronym SAST and DAST. So the power of static application security testing tools is the 100% of source code coverage. So it helps you to identify almost every vulnerability on the source code. But if, of course, you have some of disadvantages. That's why we are using the dynamic application security testing tools, and we will mostly focus on DAST software here. Um, we will talk a lot about our own DAST application security testing tools, but all this topic could be implemented on with every software you can find on the market right now. So even if it's open source or it's paid application. So a couple of words. What's the not the best part of the dynamic application security testing tools, and why we have to fine-tune it to meet the requirements of the modern applications. And the main problem is for the Wrike gas application, because it's big enterprise application and it's had a huge numbers of JavaScript code, and it's compiled, and it's huge. It's takes a lot of time even for the browser to upload it to the client and then to use it for from the user perspective. So for the DAST software, that's a huge problem. It will not even sometimes parse it correctly, and moreover, it will not analyze the software at all. Even you complete all required steps for the login, page visiting, link collection, and so on. So you will face a lot of problems and will not cover all required steps from the security perspective. So I would like to share with you the information how we initially use the DAST software in our company. So we start, I think there's almost everyone use the DAST in previous pages or previous years. So we're using the simple cron job that's launched for every night, the scan of your software, your tomorrow release candidate for the security vulnerabilities, and we were using the plugin Carbonator. It's enlarge our DAST software interface to support spider crawler active scan activities, and we're using simple bash scripts to send emails to this security alias that's, hey man, there is your HTML report of the security vulnerabilities I have found this night, please take a look. So you have to manually analyze every report every day, and even it's broke on some spider task, it will not complete at all or send you the empty report, and you have to figure out what's going on, and you have to relaunch it manually and so on. So this was a quite bad experience, so we have to implement another way to do this. So then we move to the continuous delivery process. So we enlarge our DAST software with the Web REST API. It's our own limitation from our continuous integration software, so we have to use the web interface. But one big difference here that we implement the with our own backtracking Wrike system integration. It helps us to upload the HTML reports directly to the tool we are using every day, and we don't have to move to the email and take a look at the each vulnerability. But of course, there were a lot of problems at all. So we move to the another way, and that's what's my topic about. So how we decide to change the process of how we analyze the software from the security perspective. So this is how it looks like. I will tell a couple of words before we start with technical details. So every department right now, I mean software development department, have the quality assurance team, and at Wrike we have a great quality assurance automation team, and it's implement their own software testing framework. It's quite simple. It uses the common Selenium web drivers to launch smoke tests to verify that our future release candidate is works as planned. So it's run before every deployment process. So they check the main business logic tasks. For example, user can log into the application, user can open specified pages, and he can do some kind of job, and so on. And we think that it will be great to use their own experience in our security perspective, because it helps us to simulate the same thing for the security department and focus on the exactly things that were changed on the software. And you don't have to focus on, as we did on the blog pages with a number of millions of events that were created for the 10 years of our company. So your DAST application spends all the time from the night just for looking for the same pages, but the spider think that they are unique, and so on. And you don't have to manually figure out that the freshly created pages are not the same from the CMS or any other software you use for your blogs and so on. So that's the main point. So how it looks like. The continuous delivery system checks that our DAST application, we are using the Burp Suite Professional, are alive, and here help us the special created REST API interface from the Burp Body open source plugin. We enriched it with a couple of features, but the main functionality seems the same. So we check that it works as planned, or it restarts the Burp server, and it creates a new instance to create new scan. Then it send requests to the Selenium and ask the Selenium to start the test, which I used to start on the release candidate for this day. And the continuous delivery task also ask Selenium WebDriver not to send the request directly to the application, but proxy to the Burp Suite server, and tune the certificate chains to meet the requirements, and all results are passed to the our release candidate. So after the all required tests are finished, CI asks Burp server to perform static or dynamic auto analysis. And after the job is done, it sends all the results to the backtracking system. So a couple of more details on each step to make sure everything is clear. So you have to identify what kind of tests you are most interested in. So we are interested now in our authentication authorization tasks. Our critical operations is all about check user rights to perform any work or task on our software. So we would like to know that user have enough access to perform some account management stuff and so on. We perform a very simple WebDriver. It just extends the normal WebDriver with a simple proxy server and certificates. And the CI tasks are pretty simple, so it's just check that DAST is alive, launch QA test, wait is for finished, and launch the Exoscan. REST API, a couple of words about some useful stuff we implement from our side. So it's just check is it alive, restart the proxy, fine-tune the scope, and send result to your backtracking system. And the most interesting part here is about the merging of the found vulnerabilities. So as I told earlier, to minimize the work which should be done from the security engineer every day, we create this some kind of special unique identification process. So we just collect the hash of the name of the issue, URI where we find the issue, and the severity. It helps us to merge results from the previous days, which we know that exist. For example, some vulnerabilities, but they were suppressed by the security engineer for some reason because it's not a real one, or maybe we are fine with this kind of vulnerability for our software because it's not a bug, it's a feature. And it helps us to identify the results we previously found with SAST software, and we will talk about the SAST analysis integration a little bit further. So how it works for the SAST. So the problem, dynamic application security testing tools know nothing about the source code, and we should to learn it how to find the issue on the source code. And for these purposes, we are using the SAST software. How we did this? We have special SAST engine, and it creates the same hash map for the URI. So it helps us to identify which route for the web server matches to the exactly source code and exactly class where the software SAST found the vulnerability. And we calculate the same hash and help us to identify where it's previously found or not, and help us to fine-tune the engine. So a couple of examples. So this how it looks like usually. So this is the DAST perspective. So it's just simple JSON object where the all results from the DAST software vulnerability scanner are transformed. So we know the URI, we know the name of the issue, issue background, and the same stuff from our static code analysis tool. It's know the handler. We are called handler, so it's just the route to the web server URI where the source code will be mapped by the software and the lines of code if it was previously found. And a couple of words more about the examples, real examples, which we were able to find on our software on the stage of release candidate. So it wasn't delivered to the production, and we don't have to purchase it as sub. So a couple of words of fuzzers, because we don't use the raw dynamic application security testing tool because it's not suits our requirements for the vulnerability engine, and we would like to improve it with some our built-in house fuzzers, and they are built on top of the Radamza. Radamza is a great fuzzer which use the input data, transforms it some way, and then send to the web server and are trying to identify is it correct behavior or it looks like a vulnerable one. So is it as it is a testing environment, we have enabled this error logging and so on, and we can use the error responses to identify issues more accurate than usually when you just get the 500 error without any details. So how it was? So DAST identify the handler and the plugin highlights that he was able to successfully modify integer per load, and he just mutated the numbers and figure out that he got response not not the usual one response. So it's told us that the value wasn't found on the database, and it's usually told for our system that he can successfully pass all the required security testing checks. So that's why it's highlighted as a high-level severity issue, because it allows user to get access cross account in our applications. It's critical for the SaaS software as the Wrike is. And from the static code analysis tool, there is another problem, because the SaaS have 1,000 of these kind of issues for our software, because it didn't understand our rule policy, and our rule policy are not so good clarified from the source code perspective. So it's usually have to be done by the direct user, and there's some kind of problems for us to understand it from the just SAST perspective. So we map the humorous numbers of issues with the directly one and can highlight, hey, take a look, this looks like we found the real issue because we are alarmed with two different kinds of software at this point on the same issue. And it creates on Wrike the task, and we can assign the required developers to fix it before we go to the production. That's all. Thank you very much. Hope you enjoy.